Tensees, we prepare ourselves this lesson to go from just the parts of a line, this whole slope stuff, to let's start looking at equations of a line. There are three equations that we will be using that can create lines for us. The first one, the focus one, the most important one, is the slope-intercept form of an equation. Now, on page 18, slope-intercept form of equation, you are going to see this formula equation quite a bit at this point. That's the equation for any line. The reason being, y and the x, the y and the x basically are any 2 points, x, y, on the line. But what's more important to come up with the equation or the slope-intercept form of a line is the m and the b. The m, as we know, represents the slope of the line. That's going to be important. Knowing what the slope is will go into this equation. And the b is something that we've talked about, but now we're going to use it more formally. B represents the y-intercept of the line. And knowing where our line hits the y-axis becomes very important in creating the line. So y equals mx plus b. In the next 3 lessons, you are going to hopefully get sick and tired of hearing it because you understand it so well, but you're going to hear it over and over. It is an essential equation because these 2 pieces of information are so useful in what we're going to do for the next 3 lessons. Now, with that being said, slope-intercept can be given. An equation can be given in all kinds of different forms with y values, x values, and other values. But we want it in this form where y is isolated. That's essential. We always want the y to be by itself in slope-intercept form. Because when we have slope-intercept, that's why it's called slope-intercept, it gives us the m and the b value. Having the y isolated allows us to quickly identify that information. So the first thing we need to do is practice. If we look at the bottom of this page, being able to practice isolating the y. Now, to isolate a y, we use algebra steps. We need to essentially, just like we do in algebra, get rid of everything so y is by itself. We move stuff around, but understand that isolating y is about moving stuff around. We're not truly eliminating things from the equation so we get y equals 7. We want to move stuff around so that y equals mx plus a b. So let's just start looking at it. In this first one, in order to get y by itself, we need to get rid of the 3. Algebra tells us, what do I mathematically need to do so that the y is by itself? Well, they're attached by multiplying, so I'm going to divide by 3, just like we would in algebra. Whatever I do to one side, I do to the other. So by dividing by 3 on the left, y is now by itself. But on the right side, because we have 2 terms, we need to divide both terms by that 3. So we have 6x over 3 plus 9 over 3. Now 6x over 3. 6 and 3 I can divide. The x just stays by itself. 6 divided by 3 is 2x. 9 divided by 3 is 3. So what do we have? We have y isolated, and we now have y equals mx plus b. Our slope is 2. Our y-intercept is 3. We didn't know that at the beginning because y wasn't by itself. But when we manipulate to get y by itself, well, now I can identify slope, intercept, and that's going to be useful. Second one, want to get the y by itself, have to get rid of the 2. They're attached by multiplying, so I divide by 2. So I'm going to have to divide both pieces over here by 2. That's going to leave me with y, but now I have x divided by 2. That's a little tricky. So x divided by 2, what number could I put up here with the x? Well, it's like saying you have 1x. Subtract 5 divided by 2. So in this case, 1x divided by 2, 1 divided by 2, I don't want a decimal, I want rise over run. So it's just going to be a 1/2 x. Subtract, leave the value in fraction form. So we had an initial form where it was 2y equals something, but we now isolate the y, and once I have that, well, now I know 1/2 is my slope because y equals mx plus b. So my slope is 1/2 and my y-intercept is a -5/2 or a -2.5 if I go into mixed form. So this slope-intercept y-isolated form is much more beneficial. Question 3 is one that throws students off because they say that y is isolated, but it's not isolated because we have this negative out front. Sometimes by putting a 1, whenever I have a variable by itself, there's always that coefficient of 1 that's assumed to be there. So what would I have to do to get y by itself? Well, I want to get rid of -1, which is attached by multiplying, so I divide by -1. And I then have to divide the other side, all parts of it, by -1. And we're left with y. -2 divided by -1 is +2 with the x. 6 divided by -1 is a -6. Initial form, y is not isolated, but now it is. So I know my slope is 2, and my y-intercept, b, is -6. Y equals mx plus b, so our b is -6. Having it in the correct form is essential. 4, 5, and 6, a little bit more involved here. Well, for 4, we need to get y by itself. So the first thing is I want to move everything away so that I can just have this y term by itself. So if I have a 2y, I want to get rid of this 16x, and I want to get rid of this -8. Well, they're attached by addition, so to get rid of a 16x, I subtract 16x. Because 16x minus 16x makes it disappear, but I have to do the same thing to that side. And I have a -8. How do I make a -8 disappear? I add 8. So I add 8, it disappears, but I add 8 over here. So I now have 2y equal to -16x plus 8. You'll see the more you do this, I'll stop showing those steps over and over. Understand that if I take a value and get rid of it and move it to the other side, my positive 16x, by subtracting 16x, it just becomes a negative. My -8, by moving it to the other side by adding 8, all I'm doing is moving it and changing the sign to a positive 8. So it's a little bit of a trick to speed things up. But we still don't have y by itself. I need to divide by 2, divide both of these parts by 2, so I'm left with y equal to -8x plus 4. There's my y equals mx plus b form. Slope, -8. Y-intercept, +4. All of that. But this initial form told me none of that. So putting it into y equals mx plus b slope-intercept form gives me important information. Pause the video, try 5 and 6, see what you come up with, and then we can do them together when you come back. Give it a whirl. All right, here we go. We want to get the y term by itself. But this one's a little different. You should end up with the same answer, but I'm going to show you something. This is a -3y. We want to end up with a positive y. So rather than moving everything away from it, well, here's the trick. Let's actually take the -3y and move it to this side. Because how would I get rid of a -3y? I would add 3y. -3y plus 3y gets rid of it, so I add 3y. Moving it to the other side, what did it do? Just change the sign on it. So there's a bit of a trick. If you see a -y term, move it to the other side, and that way my 4x and 12 stays where it is. What do I want to do now? I want to get y by itself by dividing by 3. Divide by 3, divide both of these parts by 3 on the other side. 4x divided by 3, well, there's my slope, 4/3, 4 to 3x. Plus 12 divided by 3 is 4. That equals y. I'm just going to put the y out front over here. It doesn't matter which side it goes on. Y is equal to 4/3 x plus 4. What's nice, the initial form didn't really tell me much, but slope-intercept now tells me slope is 4/3. My y-intercept is 4. And number 6, building on that same idea. Everything's on one side. It's a -y. I don't want a -y. Let's move it to the other side. Add y. -y plus y gets rid of it. Plus y, there's my positive y. I still have a -x minus 11. So really, what does y equal? -x minus 11. Interesting case. There's my isolated y. Y equals mx plus b. In this case, what is my slope? I don't have something with my x. Don't forget a variable by itself. Our slope is -1 there. And our b-intercept, or our y-intercept, which is our b value, is -11. Isolating y gives us the slope-intercept form, which is going to be more usable. You'll be doing a lot of this manipulating in the next few lessons. All right. Now that we know how to isolate it, we're going to graph lines on our calculator. So graphing lines on the calculator, very step by step. First thing that's most important, remember, has to be y equals mx plus b form. Then there's the process. You always, and we'll look on a calculator in a second, we want to start by hitting this y equals button. That gets us into the graphing function. It must be y equals mx plus b or it won't work. When you go to input, there is a button on your calculator that has an x, a t, a theta, and an n. That's the button we push for x in the equation. It's your variable button. Once we've hit y equals, once we've gotten into slope-intercept form, well, we input the equation into y1 equals. And then we'll hit graph. Note that it says y1 equals. It gives you options to put in several equations for several lines, but it's always y equals. That's why we need slope-intercept form. Y equals mx plus b. So that's what we're going to put in. So if we take a look at page 19, it gives you 4 lines there. So I want you to go into the graphing and punch in those, input those 4 lines to be graphed. So your calculator, there it is. What I want to do with this, if I just first of all go as if we're in the calculator mode, top left button, there's your y equals, the very top left. It's now highlighted red. We can put up, in mine, up to 9 line equations on. You see that it's y1, so y equals. I want to put in 2x plus 5, so I'm just going to put 2. There, highlighted now in red, is your variable button. xt theta n, 2x, and then plus 5. There's the first line. Scroll down, because I want to put all 4 lines in to start. Second line is 3x, using that variable button, plus 5. Then I want to input. Now, subtract 6x plus 5. It's not a subtract, it's a negative. It's important that you hit the negative button at the very bottom like I just did. It's highlighted red. You don't want to hit subtract. If it's a subtract sign, it won't graph properly. So we want to make sure we're hitting negative 6x plus 5. And then finally, scroll down for the last one, we have 0.5x plus 5. There's our 4 lines. Looking at those 4 lines, what do you notice about those 4 lines? Well, we have the same plus 5, plus 5, plus 5. And what is that in our slope intercept? That's our intercept. We can see on this that our slope is different for each equation, but our y-intercept is 5. Every one of these lines should be going through the y-intercept at positive 5. Very top right, we can now hit graph. There it is. We see that all the lines are on a different angle because they're different sloped, but they all pass through the y-intercept of 0,5 because 5 was the y-intercept. That's how we graph. So with that being said, go back to y equals and clear each of those. So y1, you just hit clear. Scroll down, hit clear. Scroll down, hit clear. Now what I want you to do is second bottom part of 19, it gives you another set of 4 lines to graph. Note, what's interesting about all 4 there? Negative 3x minus 1, negative 3x plus 6, negative 3x plus 2, negative 3x. They all have the same slope, but they have different y-intercepts. What do we know if lines have the same slope? They should be parallel. Well, let's try. But remember, don't put in subtract 3x. Make sure it's a negative 3x minus, now it's subtract 1. Notice if you take a look, the negative's a little smaller and raised a bit compared to a subtraction. Keep that straight. Scroll down. The next equation, negative 3x plus 6. Negative 3x plus 6. Then we want negative 3x plus 2. And then we want just, if we go down, another negative 3x. In this case, like we just said, slopes are all the same with different intercepts. When we hit graph, slopes are all the same. They contact the y-axis at different intercepts, but they're all parallel. So that's how we graph. So if I just want to go in and I'm going to clear those because I don't want those for later on. And now what I can do is I'm just going to close my screen. So we'll talk window settings here in a couple minutes. But what's similar about all of these first ones? They all passed through the y-intercept 0, 5. And that made sense because the b value was 5 in all the equations. So we can see that in y equals mx plus b, that b value is the y-intercept. Well, then what did we do? Then we graphed this next set. And what was similar about each line? They all had the same slope, which was slope of -3. What did that mean? All the lines were parallel, which they should be because we just talked about that last lesson. Same slope. We saw that slope -3, because they were all the same slope, they were parallel. And if you recall, they were all like that, negative slope, they were all going in a down direction. So it all ties together. What we're talking about makes sense. All right. I want you to practice putting in some of these and seeing the intercepts because they're important, the y-intercept. However, I just go back to this page that talks about how to graph. I ignored this bottom part to start. Sometimes you won't see the whole graph, or more importantly, you won't see the intercepts. Intercepts are important. The window button helps you to change what you see. You don't want to change a lot in there, but there's something that says x min, x max, y min, y max. Those are the key parts to changing settings. Because if I have just a regular Cartesian grid, usually I suggest you set all these to -10, -15. If everything's -10, and +10, you'll see 10 going this way, 10 going that way, 10 going up, 10 going down. But if I change x min, x max, y min, y max, we start to see different parts of the graph. If I put my x min and I changed it and say I had everything, all my mins were -10 and my maxes were 10. If I changed my x min to say -50, well, here's my x-axis. Right now it goes to -10. If I changed it to -50, I would still see 10 up, 10 down. I would see 10 for my x max, but my x min would now go to 50. And that's sort of how it would change. I would see way more on the minimum side of my x than the other parts because I set it to be a lot longer. So we'll see as we do some examples how we can play with that. So let's go to this question here now. Back to page, if you look at page 21, page 21 gives you a whole bunch of graphing that can be done. Now with all that graphing, you're going to have time to practice on some of them. I just want to take a look at 4 of them. Make sure you understand what's going on. So if we take a look, y is equal to 2x plus 9. Should actually be a 4x plus 9. Sorry about that. The very first one is y is equal to 4x plus 9. So I want you just to graph number 1, number 3, number 5, and number 7. Let's see what those look like on the graph. So y equals 4x plus 9. Again, we hit y equals to go into the, put in your equations. And now we go 4x plus 9. If I hit graph, there it is. Now even with this, we can see the x-intercept no problem, but the y-intercept, we can just barely see it. Well, what could I change so that I see more? This is where up at the top, our window button, right beside the y equals is the window button. It's now highlighted. You see that we have x min, x max, y min, y max. Those are the 4 to focus on. Those are the 4 we want to focus on to change. So if I go back to the graph that I had, and I do that if I'm in here just by hitting graph again, what do I want to change? If I want to see more up here, that's our y-axis, and those are the maximum values. So I want my y max to be larger than it is. So we can go to window, and I scroll down. I'm okay with my x's, my horizontal, but I want my y max to go higher. So I can hit clear, and instead of 10, let's just change that to a 20. So everything's the same except x min, x max, y min are the same, but my y max, I've changed it to be twice as big so that it's going to show me more. I hit graph. It's the same line, but now we see that the scales become a little smaller to fit it, but now we see a lot more on the y max side. So there's how the window can work. So let's try graphing another one. Back to y equals. Let's clear that. The next one was negative 32x plus 14. Make sure you hit negative, not subtract. Negative 32x plus 14. Let's graph that one. All right. This case, we can see that it's going fairly steeply. I don't need all of this graph over here necessarily, but I would like to see it up a little bit more. So what needs to change? My x max, because this is to the big values, and my x to the min. I could bring those in a bit, but I still, even though I changed this earlier, my y max needs to go higher. So let's go into window. The x values we just talked about, we want to bring the x min in a bit. So let's just change that to a negative 5. Negative, not subtract. Our x max, let's bring it, instead of being way out to the right, let's bring in a bit and say we just want it to be at 5. And again, y max, this one, we want it to go even higher. Let's go up to 40 and see what happens. So I changed x min and x max to bring it in, but I want to go higher. Let's hit graph, and there you go. You can see it a little bit better. You can also see that our scales change. They're not consistent. This is 1, 2, 3, whereas 1, 2, 3 happens there. But we can see more of different parts of the graph by changing the window. So let's go back to window. Let's just go back to, I'm going to go negative 15, 15, negative 15, 15. Please be careful. Sometimes I'll have students that for x min put 15 and x max put negative 15. If you mix up, it'll say it can't graph it. Your maximum can't be smaller than your minimum. So you have to watch little things like that. That's a common error that students will make. So we hit y equals. We're going to clear that. Let's do the third one now, which was 1/2 x minus 7. Now, if I want to put a fraction in, I realize 1/2 could be 0.5, But sometimes we have to put in fractions because they don't terminate as a decimal. To put in a fraction, we bracket and we go 1 divided by 2 so it looks like a fraction and close it in. There's a half with the x and then subtract 7. Y is equal to 1/2 x minus 7. If we graph that, well, I see the y-intercept really well, but I can't see the x-intercept too well. So we can go to window. If I want to see more over here, what am I changing? That's the x-axis and the maximum values. So I want to change my x-maxes to be larger. So I go to x-max. Instead of 15, let's put 30. And let's graph that. There you go. Now my window displays both intercepts nicely. I can see the important parts of the graph, and I could work with it from there. Last one, y equals, let's clear that, was the 25y plus 6 equals 19x. Well, this last one, we can't put that last one in because it's not slope-intercept form. The y is not isolated. So what do I have to do in order to isolate the y? Well, first thing is I need to move my 6 over. That'll leave me with 25y. If I take a positive 6 and move it over, I'm still going to have my 19x, but my positive 6 will become a negative 6 over there. Now I divide by 25. I have y by itself. I need to divide both of those parts by 25. What am I left with now? Now I'm left with y equal to 19/25 x minus 6 over 25. There's what I want to graph. Complicated because of fractions, but that's the slope-intercept form we want. So what do we want to put in? Y equals 19/25x. So bracket 19 divided by 25. There's my fraction with the x. Fraction in brackets x. And I then want to subtract 6 over 25. I still put 6 divided by 25 in brackets to identify fraction x, subtract a fraction. Fractions always go in brackets. We hit graph. Look at that. Nicely laid out. We could make everything a little smaller and consistent since it's right around the vertex. I could change everything to negative 10 and 10 if I chose, making sure my mins are the negatives and my maxes are the positive. And there you go. There's your graph. So that's how we graph y equals mx plus b on the calculator. So let's keep going from there. Now, with that being said, there's other things that we can do on the calculator. What are the key components of the graph? We've just looked at graphs like crazy. And I keep referring, if there's a graph that I create, just so it's a different color, what's important about the line are intercepts. So the two key things, x-intercept and y-intercept, we can get off of the calculator as well. Here's how. Pretty straightforward, but you got to remember it because this will be required to know. You are going to graph the line on the calculator, but to get the x-intercept, you will hit second function and then the trace button up at the top. You will choose 2 for 0, and then you will follow the prompts using the arrow keys to get the x-intercepts. Now, what's important when you have a graph? What it's going to say is to get the x-intercept. The x-intercept is here. And the calculator is going to prompt, set the cursor left of the intercept. Well, you have this little flashing cursor that moves along the line. When it says left of the intercept, if that's my intercept, I want to be on that side of it. So I would have to move my cursor above. That's left of the intercept. You would hit enter. Then it prompts you to be right of the intercept. So I then want to take that cursor, and if that's my intercept, if I want to be on the right side of it, I would have to move it down here, because that would then be right of it. That's what they mean by left and right. Now, with that being said, if we have a positive, and there's your x-intercept. If we want to be left of the intercept this time, it's that way, so we would have to be below, because left of the intercept takes us below. Right of the intercept is this way, we would have to position the cursor above. So that's, if you have this page 20 in front of you, what you can work with. That's what we can use to come up with these values. Y-intercepts, you're going to graph the line, second trace, but then you choose number 1, the value. This says, what do you want to use for x? Well, if we want the y-intercept, we want x to be 0. So have this sheet in front of you, and let's take a look at a few more questions. So this time, what we're going to look at is we are going to get the x and y intercepts of the fourth one down, y equals 22x minus 18. Sixth one down, y is negative 2/3 x plus 32. And then we'll do, we'll skip the third one. We don't need 4 examples. Then we'll do second from the bottom, 8x minus 14 equals negative 7x plus y plus 10. So we're going to get the x and y intercepts of those. But let's take a look at here first. We need to create slope-intercept form. We need to get y by itself. I like this y because it's positive. That means if I want y by itself, I'm going to move negative 7x over there to the left side. By moving a negative 7x, I'm adding 7x. I need to take my positive 10 and move it to the left side. And a positive 10, when it changes sides, becomes a negative 10. So moving the 7x over, I get 15x. Moving the 10 over with negative 14 and negative 10 is negative 24 equal to y. There's the slope-intercept form we would need to use because we have to have an isolated y. So let's take a look back at our calculator and play around with the x and y intercepts. So on that page 21, we want to start y equals, clear the one that was there. The first one was y equals 22x minus 18. 22x minus 18, and we want to graph it. Well, we have our x-intercept, but we don't have our y-intercept. We need to go down. So that means our y-axis minimum value needs to change. So y min, we need to be lower than negative 10. Let's go negative 25. Does that give us our intercepts? Barely. I'm going to even go a little lower so it's a little more distinct. I'm going to go down to negative 40. So now it's easy to see my intercepts. So here we go. How do we do these intercepts? Start with second trace. To get the x-intercepts, we choose, go down and choose the 0. Hit enter. Here's the prompts I was talking about. We want to be left side. There's our intercept. If I want to be on the left side of that, I need to use my arrows to be close to the intercept, but make sure I'm on the left side of it, which in this case is below. I hit enter. Now the prompt is to be on the right side of the intercept. Well, to be on the right side of the intercept, I need to be this way of it. So I need to move my cursor so I'm on the right side of the intercept. Hit enter. Now what is the calculator prompt? Would you like me to guess? Please, yes, we want you to. So we hit enter. And where is our x-intercept? You can add this onto your sheet. The x-intercept is at 0.820. There's your x-intercept. Second part to this, I don't have to change anything. I can go second trace because now we want the y-intercept. What do I choose for y-intercept? Well, the instruction sheet tells us to choose one value. We hit enter. If I want the y-intercept, which is somewhere around here, I know that my x has to be 0 for any y-intercept. So all I do here is put in 0, hit enter, and where's the y-intercept? It's at 0, -18. There's how the x and y-intercept can be found. So I'm going to go back to window. I'm going to put everything back to -10s, +10s as a good starting point. Graph it. Now I go y equal, clear, and now I can try my next line. The next line was y equals -2/3 x plus 32. So y equals, we need the bracket, -2 divided by 3. There's your -2/3 x plus 32. There's the line we want. Let's hit graph and see what it looks like. Look at that. We don't even see it. Well, if I'm not sure where my graph is, I'll go to window and I'll just go -50, 50. -50, 50. And graph it. Oh, now I see it. Now what's important to understand is with this, some of you may have already noticed this line -2/3 x plus 32, for our y-intercept, x equals 0. So if I have -2/3 times 0, it goes away. There's my y-intercept. I know I have to be up at 32. So that gives me an idea as to where to start my window values. But anyways, I've got it. I don't want tons of information here. I can bring my y min over. I can bring my x min over. I could bring my y max down a bit, but I might even want to go over a bit more for my x max. So I can change all kinds of things on this. My arrows are still there to help me. So my x min, I can bring over a whole bunch, -10. My x max, we actually see we wanted to go over a little bit from the 50. So I'm going to go to 70. My y min, y down, we saw could come way up. So let's go -10. And our y max, we wanted to come down a little bit. Maybe I'll just change my y max to 30. So with those changes, now I hit graph. Came down too far. I need to change my y max back up. Let's go to 40. And now I can see my x and y intercepts. Now I can use them. So second trace, we want x-intercepts is number 2, zeros, we enter it. So the x-intercept, we want to be on the left side of the x-intercept. So I scroll down towards it. There's my x-intercept. I want to be left of it. So I want to be above just like I am. I hit enter. Now it says right bound, so I want to be on the right side of my intercept, which in this case, as I move below it, it moves right of it. Hit enter. Please guess it. And there's our x-intercept, 48, 0. We're at 48, not going up or down. There's the x-intercept. And now, second trace. How do I get y-intercept? I hit number 1 value, enter. What do we want x to be? 0, but we already showed. Enter. It's at 32. So there's our y-intercept, and you can add that. Now the last one that we worked with, let's go back to y equals. We'll clear that. Was second from the bottom. We rejigged the equation, so it was slope-intercept, 15x minus 24. Graph that. Now we see that our intercepts are all mixed up again. What do I need? I need to bring my x max way in. I can bring my y max way down, but my y min needs to go down so I can see my y-intercept. So window, x min was okay. X max needs to come way over. Let's go to 20. My y max needed to come way down. Let's go to 10. My y min we saw needed to go down. So let's take it negative 30 because I'm not exactly sure how much. So we can play around with it till we get what we need. In that case, I have a nice x-intercept. I want to bring this down just a little bit more so it's a little nicer to see where exactly the y-intercept is. So my y-min, I'll take down to negative 40. Graph that. There I go. Intercepts are nice. Second trace, get the x-intercept, which is 0. Scroll so that you're on the left side. Oops, scrolling the wrong way, sorry. This down here shows you where your cursor is at. Right now it's at x5. So my cursor would be somewhere up there. So I see that I want to keep bringing it to the left. And I want to be on the left side of my intercept, which is this case is below. Right side of the intercept above. Please guess it. There's your x-intercept. X-intercept, 1.6, not going up and down, which is what an x-intercept is. And the y-intercept, second trace, number 1 value, x is 0 for an intercept, y-intercept, it's at negative 24. So there is what you're looking at for using your calculator with lines. Being able to do it with the calculator is one thing, being able to work without calculators another. All right, a bit of a long video because of that calculator work, but here we go. Manually graphing slope-intercept form. Really, we've already done this. We can do it on a calculator, but manually doing it, when we have y equals mx plus b, we've done this before. We graphed using slope, which is what we want to do. Because b, the y-intercept, that's your starting point. I can put a y-intercept onto the graph to start with, and then I can move the slope, which we did last lesson. So those are your 2 steps. Intercept and then move the slope. Here we go. Y is equal to 2x plus 5. Graph the line. Y equals 2x plus 5. What do we know? We know B, our y-intercept, is at 5. So it's 0, 5. The y-intercept. There's your starting point. We know our line goes through there. What else do we know? We know the slope is 2. So I can move the slope, which is 2 over 1. How does that tell me to move? 2 up on the rise, 1 right because they're positive. What else could I move if I wanted? -2, -1 is the same slope. I could go 2 down and 1 left. So from that point, I could go 2 up, 1 right. 2 up, 1 right. Or 2 down, 1 left. 2 down, 1 left. 2 down, 1 left. Moving the slope allows me to create the appropriate line for a line. But why is it easy to graph this? Because it's in slope-intercept form. We have the slope, we have the intercept, nice and easy, because we've already done it, just not with an equation. So, page 22, number 2A, 2B. Let's try it real quick. Here we go. What do we know for this slope-intercept form? Because the y is isolated, we have a b or a y-intercept of 4. So at 0, 4, we have a starting point. We also have a slope of -5 or -5 over 1. What does that tell me I can do? That means I can go 5 down and 1 right. 1, 2, 3, 4, 5, 1 right. 1, 2, 3, 4, 5, 1 right. I don't need anything more than those points. Those points will give me everything I need in order to create the line given by, given by my equation. B, a little bit trickier because we don't have slope-intercept, which is essential. What can I do to get y by itself? Excuse me, 2 things. I could move my 3x and my 4 over to get y by itself, but I don't want to do that. This one, I notice that my y is negative. I don't want a negative y, so I'm going to move it over. That then gives me a positive y by moving it, and I have 3x plus 4. There's my slope-intercept. My intercept is at 4. My slope is 3, or 3 over 1, which means it's up 3 over 1. Or down 3, left 1. Down 3, left 1. There's what my line looks like. I can connect points. And there's what the line looks like for -x plus 3x plus 4. As long as I'm in slope-intercept form, it's easy to work with. Try on page 23, C and D, see what you come up with. All right, here we go for C. Hopefully you noticed with C that y wasn't by itself. I like the y because it's positive, so we move the 2x over. That's going to leave me with a y by itself. When 2x goes over, it becomes a -2x, and it's with the positive 5. What does this tell me? My y-intercept is 5. My slope is -2, which could be thought of as -2 over 1. Intercept is at 5. Slope, down 2, right 1. Down 2, right 1. Down 2, right 1. Keep going. And now I can graph that. And there you go. there's the line to represent that equation. Y is equal to negative 3 over 5x plus 1. Y is isolated. We have slope-intercept. Intercept is 1. Boom. Slope is negative 3 over 5. It doesn't matter where the negative goes. You can put the negative in either position. You're either going to go 3 down, 5 right, or you're going to go 3 up, 5 left. Either way works. 3 down, 5 right. 3 down, 5 right. Or 3 up, 5 left. Either way, I get all the lines, all the points in a straight line, which they should be because they represent a line because we have slope-intercept form. So, keep plugging away here. A little bit longer because of that calculator work. But, page 23, E, negative 4x equals y. Confuses some because y is negative 4x. But in all honesty, if y is negative 4x, well, I'm just going to rewrite it this way. This gives us our slope, which is negative 4. But what's our y-intercept? We're not adding a b value, so technically, that's a b value of 0. So our y-intercept is 0 and a slope of negative 4. We see the line going down. But if there is no b value, it's a b value of 0. F, y is equal to negative 3. Interesting one, because in this case, y equals mx plus b. Well, we don't have an x at all. So it's kind of like saying, what's our x value if it's not even there? X is 0, and b is negative 3. Well, negative 3 is here. Slope of 0. What does slope of 0 tell us? Horizontal line. So we get a horizontal line through the intercept of negative 3. Seems tough, but really, it's those little things that you have to remember. All right, with that being said, page 24. Well, when we go to page 24, what's important here is the idea of horizontal and vertical lines, which is at the bottom of page 24. Anytime, and we've talked about it a little bit, any equation in the form y equals a value, so y equals 2, it's a horizontal line. Because like we just said, y equals mx plus b, well, all we have here is the 2, which means our slope is 0, which is a horizontal line. So the other way I like to think of this, if y equals 2 and I do a table of values, I know that y has to be 2 in every situation because it says y is 2, which means my x could be anything, negative 5, 0, 5, whatever. But at negative 5, y is 2. At 0, y is 2. At 5, y is 2. So y equals is a horizontal line. Another way to think about it, y equals 2 says y, everything should be up 2 on the y. Everything should be up 2, which is a horizontal line. So with that being said, when we have x equals a value, it's the opposite. We have a vertical line. M is undefined. Again, a little tricky, but just getting used to identifying. Table of values. X equals -3. X is going to be -3 no matter what. Y could be anything. -2, 0, 2. So when X is -3, Y is -2. X is -3, Y is 0. X is -3, Y is 2. We see that when X equals something, it's a vertical line. Another way to think of it, X equals -3, everything moves -3 x-axis wise. Everything on the x-axis is -3 over. Horizontal and vertical lines. Tricky, but you just need to remember it. So if we look at the next page, 25 at the top of the page, using that same information. We want to draw the graph of 2y minus 4 equals 0. Well, we need to isolate the y. Move the 4 over. 2y equals 4. Divide by 2. Y equals 2. What does that tell us? Y equals 2 is a horizontal line. We want to be 2 up, positive, on the y-axis. Y-axis, 2 up, there's our line. Boom. D, draw the graph of 4x plus 20 equals 0. Well, here we don't have a y, so let's isolate the x. 4x equals -20, divide by 4, x equals -5. When x equals something, we get a vertical line. Everything has to be 5 left on the x-axis. 1, 2, 3, 4, 5. Everything has to be at x -5, which is a vertical line at x equal to -5. Horizontal and vertical, special, unique situations for graphic. Back to page 24, using this information that we just talked about. We have a whole bunch of lines on here. We want to create the equation. Well, what do we need for the equation? We need slope and intercept. So if we take a look at line 1 here, first thing we can find, what's our intercept? For that line, our intercept is at +1. What's the slope? Well, what do I want to do? I want to find a couple points on that line that are distinct points of intersection so that I can come up with my slope. Rise, 2, run, 2. So my slope is 2 over 2 for line 1, which is a slope of just 1. Well, now I can create my equation. Because my equation says y equals m, which we know is 1, x, plus the intercept, which is a +1. So y equals x plus 1. No need for this 1 out front. That's all we want to do is figure out our slopes and our intercepts. Let's take a look at line 2. Line 2, here we are, heading down. Right away we know our slope should be negative, so let's hope that it turns out to be negative. Where's our intercept for line 2? Well, our intercept for line 2 occurs here at -2. What's the slope? I can pick anywhere. I'm going to pick that point, and I'm going to pick that point. Very distinct points of intersections. So what's my rise? 1, 2, -3 over my run. 1, 2, 3, 4. Slope is -3 over 4, which makes sense because it's a downward slope. So y equals -3/4 x minus 2, because my y-intercept is a -2. There you go. All sorts of little things that we've dealt with help us to do all kinds of things. Let's take a look and jump over to number 4. Line 4, here it is. Straight down vertical line. So in that case, when it's a straight down, sorry, I think actually, my bad, that's line 8. Line 4 is actually the horizontal line. So line 4 is the horizontal line. Intercept, we can see, is at 8. Intercept's at 8. What's the slope? Horizontal line right away, we know the slope is 0. So y equals slope 0x plus 8. 0x doesn't exist, so y equals 8, which makes sense to what we just talked about. Y equals is a horizontal line. With that being said, let's take a look at line 3. So if we can find line 3 on here. Where is line 3 on here? Oh, that's not line 8, that's a 3, my bad. So line 3, there we go. We don't have an intercept. It doesn't exist. What's the slope? Well, when I have a vertical line, the slope is undefined. So that's a tricky one, but we just talked about it. No intercept, vertical line. When we have a vertical line, it's x equals, and how far over are we? We're at -8. So x equals -8. There you go. Last one we'll look at is give line 6 a try. See what you come up with for line 6, and then we'll talk. Here's line 6 here. There we go. Little bit tricky sometimes to see with these sketches, but where's your intercept at? For line 6, intercept I have is at 7. So at 7, we can see there's our intercept. Now I need to find 2 points to get the slope for that line. I would say there's a point of intersection there, and there's a point of intersection there. So if I want to get the slope point to point, 1, 2, 3, 4, 5, in a downward direction, so slope is -5, and our run is 1 to the right. So our slope is -5. So y equals slope x plus the intercept 7. Slope intercept form. All kinds of information you can get from it. All right, last little bit. I know this one's been a long one because of the graphing, but we talked a little bit last chapter about the fact that x and y intercepts play important pieces of information and slope. So in real world problems now, the y-intercept is a starting point for the situation. And the slope is the rate of change for the situation. And we've talked about that quite a bit. So you can read example 5, but it comes down to they've rented a portable dunk tank as a fundraiser that costs $300, and the group charges $1.50 to buy a ball to throw and try to knock, as they said, your favorite math teacher into the water. Well, what's an equation that we could write for the profit, P dollars, based on the sale of the balls? Well, the profit that the fundraiser is going to make, what's the first thing we know? We know it costs them $300. So right away, it's a -$300 before they've collected any money because they had to pay for the tank. But then they're going to get $1.50 for every ball that gets purchased. So if they sell 10 balls, $1.50 times 10 would be $15, and so on. But if we take this and we write it, manipulate it a bit, and just start with the $1.50 times the ball less 300, well, what do we have? We really have y equals mx plus b. What's the starting amount in this situation? Negative $300. What's the constant rate of change? Well, they're going to charge $1.50 for the first ball, $1.50 for the second ball, $1.50 for the 80th ball. There's the constant rate of change. So a linear relation is really slope-intercept form. And once you have the equation, well, you can use it. If 75 balls were purchased, profit would be $1.50 times 75 balls less the starting amount of 300. And if you do the math there, 75, it's going to work out to be negative $170.50. So they haven't sold enough at 75 balls to make their money back. If the group wanted to raise or did raise $350, that's now their profit. How many balls did they sell? Well, again, our formula, P equals $1.50, B subtract 300. This time we know the P is 350. $1.50, we don't know how many balls they sold, but we do know that they lost 300 right off the bat. So we're going to add 300 to both sides and then divide by 150. And how many balls did it end up being? In this case, 433, and then decimal 3 repeating. So we could say that if they made that profit, they would have had to sell all that. 434 balls were purchased in order to make the $350. And then, how many balls are needed to break even? Well, break even means you don't make money, but you don't lose money. Your profits are zero. So if their profits were zero at $1.50 a ball, less the 300 cost of the tank, well, you do the algebra there, add 300 to both sides, divide by 150. There were 200 balls purchased. So 200 balls will get the $300 back and break even. So understand though, a linear relation because constant rate of change, a constant slope with a starting point of negative 300. Page 27. Jane has selected a hotel for a wedding reception. There is a fee for the room and a charge per guest for the buffet. There's your table of values. If you graph this, it's a little tricky because it's a pretty small scale. But if the number of guests is 0, because here's your guests, there's your independent changing, and the cost is dependent on the number of guests. So 0 guests would still cost $425 just for the rental. 25 guests would cost $1,800. 50 guests would cost $3,175. And 100 guests would be $5,925. Now we've missed some data in there. It's not consistent, but we can see it's a straight line, but I don't want to graph with a line. I need dots because this is discrete data. Because guests, you only have whole guests coming. You don't have part of a guest. What are the slope and y-intercept? Well, with that being said, what's the y-intercept? The y-intercept is $425. That's the start point. Because at the starting point, they haven't done anything other than just started with that amount. But now we can do a slope calculation. Now it's hard to read off of our graph, but we have ordered pairs up here. We can get slope using any of these two ordered pairs. So I'm going to use those two. How do I calculate slope? Change in y over change in x. Don't forget, these are our x values. Number of guests are independent. These are our y values. Cost, because the cost is dependent on guests. So, change in y, 3,175 minus 1,800 over change in x, being consistent, 50 minus 25. So my slope, in this case, I can do that calculation and come up with the slope, which is going to represent what? It will represent our rate of change. That's what's important. We end up with 1375 over 25. This is cost, and that's people. So a better slope would be to divide those, and what do we end up with? We end up with $55 per guest. So we have the starting point of this graph, which is our B value. We have the cost per person, which is the rate of change, which is our slope. So now we can come up with an equation. Y equals 55x plus the starting point of 425. And if you wanted, you could put different variables there because y represents cost. 55 times the number of guests plus 425. And the last one, how many guests if 15,000 or less is spent? Well, 15,000 would be our cost. 15,000 is equal to $55 per guest plus 425. Solve for the number of guests. Subtract 425, divide by 55, and what do you get? You get 265 guests or less if they don't want to spend over 15,000. But real world problems, starting point is your B, which goes into your equation. Slope is rate of change, which is your M value in your equation. Everything's tied together. Long video because of the calculator work. Only way to get good at this stuff is to practice. So, textbook, there it is. A little bit of calculator work, a lot of non-calculator work. Only way to get good is to practice. Have fun.